Welcome to this session and good morning, titled Bring Out Your Qt Side, Executing Best App Development Patterns. We had a little fun with the title this year. My name is Michael Timms. I work at Esri. I'm the lead developer on the Runtime Qt SDK. How many of you folks use the SDK? And how about App Studio or Survey123? Okay. How many C++ developers? A few. Okay. And then QML JavaScript developers. Okay. We'll cover a little bit of both in this session. It's all about kind of just some best practice kind of development and design patterns that we're going to go through. So on the agenda, I'll talk about sort of what you need to get started with the SDK for your cross-platform development environment, some of the SDK components that come within the setup, and some Qt quick controls. I'll give you some idea of how those work, how to modularize your QML code and your components, because that's really important. You don't want to throw all your code in one big QML file. JavaScript code in QML. QML runs on top of a JavaScript engine, so you can use JavaScript right in your QML code. I'll give some examples of that. QML property binding is really the meat of the UI updates, and I'll show you how that works. And models and views is another important aspect of using some data to update your view, and how that's nicely integrated right into Qt and QML. I'll show you, hopefully we'll have some time to do some testing and deployment onto my iOS device, and then we'll finish it up with some questions and answers. So on the desktop platforms with our setups, you're going to need, for Windows, you'll need Visual Studio. That can be the Community Edition Visual Studio. You just really need the compiler. Linux, Mac OS, and you need these machines because you need to compile down to code if you're using the SDK. Unlike App Studio, where you can send up the build to a build server that builds the apps for you. You'll need to get the Qt SDK and Qt Creator from the Qt company. You can go to qt.io to take a look at that and see how to get that framework. If you're building for Android devices, you'll need the Android bits, the NDK, the SDK. Ant is deprecated now. It's kind of an old slide. Gradle is really the default that's used instead of Ant, and that helps to push your apps over to your Android device. JDK is needed as well. And then for iOS devices, along with Mac OS, you'll need Xcode, and that typically comes with the iPhone SDK, which the Qt framework needs. An Apple developer subscription is needed as well to be able to push and test to your iOS devices. So there's a little bit of setup involved there. We've got it nicely documented on our website as well on developers.arcgis.com. So SDK components, use what's already available to you. So we have some toolkit controls and dialogues that we ship with the product out of the box. And the Qt framework's got a lot of nice handy tools as well. Reuse these toolkit components, subclass them, make modifications to them to get the experience that you want in your applications. There are some C++ APIs in the Qt framework that are not exposed to QML, and we try to do a good job of wrapping up those like real high demand APIs that you need, like file I/O, application settings, being able to scale your UI with a scale factor. The App Studio app framework has many more in their app framework of these widgets or these QML components that are bundled up from C++ code. Qt Quick Controls 2 is rather new. This is controls for Qt in the QML environment, and I put it on the slide this year because it's really seems like it's the direction that Qt is going for their Qt Quick framework. There was version 1 in the past that had kind of a native look and feel. It was good. It did really great on the desktop platforms, not really the best on the mobile platforms. But Qt Quick Control 2 comes with these different style themes. So you'll get sort of a default style, and I have a couple screenshots as I go through these. Material style, so you can develop your app and style it with Qt Quick Controls 2 in material style, which is based on Google's guidelines. That means your app will look exactly the same on all platforms. So you may not get the native look and feel of that platform, but your app will look exactly the same on all the different platforms. Universal style, you can specify, which is from Microsoft guidelines. And a couple new ones, Fusion styles, sort of this desktop look and feel. And the Imagine style, which I don't have a lot of experience with, but it uses image assets, so you can define these images and bring them in, and that's how you style your UI. Some more information about that is at the link I provided, Qt Quick Controls 2, on the doc.qt.io website. So now I'll drop out and I'll drop into a demo. I want to show you, I'll first sort of run the app here. This is our dynamic situational awareness app that we're developing on the Qt team. It's using our C++ API, but a lot of the fundamentals apply to QML as well. You'll see this navigation toolbar. So this is on the right-hand side of the app. Something that's just out of the box available to you to put inside of your applications. But say I want to extend this navigation toolbar, maybe add another button. Well, how do you go about doing that? So dropping down into the code, we have my navigation tool, QML, so that's the basis, that's the actual component of the navigation toolbar. It's got a bunch of these overlay buttons inside of it, which are these reusable button types that take an image and give you a clicked event whenever you tap on them. I want to add another button, so how do we do that? Well, in my main QML where I'm declaring my navigation tool, I can anchor that, and you see it's anchored to the right side of the scene view and the vertical center of its parent, which is the scene view, so that's where you see it in the center of the screen, but on the right side. And here I can just add a new overlay button. So I can nest inside of my navigation tool a new overlay button that has some functionality that I want to do, some navigation type functionality where it accesses the navigation tool's controller, and we zoom to a certain coordinate that we want to go to in the app. So it's just kind of for demonstration purposes here. So I'll save that and run that. We'll see how that looks. So now we see that we have another button here on our navigation toolbar. If I kind of come in here, say I'm browsing around and I want to go to this this place of interest, I can click that, and it put me around my baseball field area that I've specified as my location of interest. So just one quick way of taking existing components and extending them or customizing them to have the look and feel that you want. So now I want to talk about Qt Quick Controls 2. I mentioned the material theme. You can see that I had sort of this material design look and feel. We've sort of customized this app. It's almost got a little bit of a Windows feel to it as well. But we have different components in here where we can sort of see we have this material design like combo box list that we're working with. But one of the things that's really powerful with Qt Quick Controls 2 is the configuration file. So I can have all my components in QML, and I can set up the theming and the color schemes in this configuration file. So if you just want to simply change the primary color, for instance, of my application, I'll comment out the grayish primary color, and I'll specify a blue primary color for my different border. And you'll see now it comes up and it displays this sort of blue, theme to it for the primary color. And there's different ways you can change your color schemes, and that Qt configuration file is really, really handy, so you're not going throughout your code if you want to change the color of certain buttons and doing it everywhere in your code base. You can just do it in one place in the configuration file. So if you're using Qt Quick Controls 2, use that configuration file. It's really, really beneficial. The Qt company has some good documentation on how to configure that configuration file. So now I'm gonna turn it back to gray because I didn't really like that blue color too much. All right, so back into the slides here. Next up is the modularization of your QML code. So your UI versus your business logic. You want to keep your UI separated from as much as your business logic code as you can, because you want to reuse a lot of your UI, but you also want to reuse a lot of your business logic code. So you can write a lot of your business logic code in JavaScript and split that out and put that in separate .js files and bring in your QML code. And then you can declare these reusable QML modularized components as local types within main QML or throughout your code base. You can access components through custom properties. You can reuse these components in multiple apps or within the same app, which I'll show in a little bit, where we have one component that we reuse kind of a couple times throughout the app, and we customize it and tailor it towards the experience you want to get for that particular feature. So now a quick demo on modularizing the QML. So back in the application here, I'll show you quickly. We have this message feed information where we're getting these military type graphics displayed on the screen. We have a feeds panel, message feeds panel. These are sort of our real-time feeds. And you can see that we have this laid out in this list view type structure, and it's hooked up to a model, and basically what you're seeing is you're seeing an entry row for each particular feed that exists in that model. And we can style that accordingly with, say, a checkbox and a thumbnail next to the name of the message feed. And this is a particular type that we use, pretty much throughout the entire app, like say these overlays as well. The same sort of look and feel we have. This one's got a thumbnail and a checkbox and the name of the layers as well. So this looks like a nice candidate of QML code to reuse in the application. So let's dive into the code here and take a look at what we're doing. So in my message feeds QML file, so that's that panel that we saw in the right-hand side, we have this list view, and its model property is bound to this message feeds model, which is what's giving me all the data to be able to render what I need. And the delegate is really what you style the rows to look like. So how you delegate the UI to look for that row. And it's got these properties that it can override on the list item delegate class, or that component. And this list item delegate is a type that we've split out into a separate QML file. So it's abstracted out, and we can bring this in and apply it to all sorts of different types of list views. So it's just an item, and it has some public properties on it that you can get access to when you're subclassing it. And it's a row, and it contains just some nice, simple, common abstracted out code to allow you to extend it very easily. So that's really important to do if you come across types where you want to extend it in different places of your code or different apps. Break that out and modularize that into separate QML files and make that available in other places. So that's what I had for modularizing QML components. Now we get into the fun part, JavaScript and QML. So JavaScript is an engine that runs underneath the QML engine. QML is just built on it, so it can leverage a lot of the capabilities that JavaScript will give us. We can write and use existing code in JavaScript. You can bring in a .js file and call functions from it and have your own custom functions. And you can use common JavaScript objects like math and date and all sorts of different types object. They're all available to you in this JavaScript engine. So it's really, really familiar for folks that have a web background and experience with JavaScript to build native apps, because this is a native API, and have apps that run on Android and iOS and your desktop platforms. For the QML API specifically in App Studio and Survey 123, be aware of object ownership. So QML declared components live along for as long as the parent that actually owns it, that it's nested inside of, So say if you declare a QML component in main QML, it's going to basically live for the entire application lifecycle. If you're in JavaScript code, there's a way to dynamically create objects using the runtime API, and that's with this ArcGIS runtime environment create object function. So here's a nice little code snippet where I'm creating a graphic, giving it a geometry and a symbol. And this returned graphic typically by default would have JavaScript ownership. So if you're within a function, it goes out of scope, garbage collector is going to clean that up, and now that graphic's been nicely handled and deleted, and that memory management has been handled for you. If you don't want it to get deleted when it goes out of scope, you pass in this last parameter, which I've highlighted as the map view. So now graphic will not get deleted until the map view gets deleted, because the map view is the parent now of the graphic object. So that's really, really handy. People get caught up in that sometimes and wondering how the object ownership works in QML. Property binding. Property binding is definitely worth understanding for updating your UI whenever your properties change. In QML, a lot of the times this just handles for you. So the QML engine monitors these properties, and whenever they're bound to UI, it'll go on there and reevaluate the property and update the UI accordingly. So I've got some examples here where, say we have a component that's got a height, and we set that to half of its parent's height. So it's sort of, nested within its parent. Whenever I'm dragging my window, say on a desktop platform, to change the height of my parent, the child height is automatically going to update because it's bound to the parent height divided by 2. So you don't have to write a whole lot of that code to do that logic and update your UI. The property binding is going to handle that for you. And there's all sorts of different use cases for property binding. This is just one of the simple use cases. There's also Qt.binding, where you can bind to a JavaScript function. I don't use that so often. It's not as used as the former that I showed, but it does exist, and you can get some documentation on how to use that. So JavaScript and property binding. So I'm going to run this application again. And we did sort of show the overlays, which is this table of contents. And we can choose to click on this little ellipsis type button at the end of the menu. And we have a couple options here. And say I want to zoom to this particular layer. So I have this like boundaries layer that I can zoom to, and I can execute some sort of command when that occurs. But also I was calling some JavaScript code when I clicked on this menu as well to bring up the menu. So let's see how we're handling that and using JavaScript to update our UI. That's not what we want. So here we are in our table of contents QML. And we have this mouse area that's covering that ellipsis button that was in our menu. And we can put a mouse in area over the top of it and fill that to cover up the button. So whenever you click on that button, the mouse area is going to intercept it, and it's going to fire this on-clicked event. Now when you're in this code, in this on-clicked code, you're working in JavaScript code at that very moment. You're writing your business logic, and you're doing whatever you want to do in JavaScript code. For instance, here we check if we're mobile, or if we're not mobile, and we open up a certain kind of menu. Else, if the property is mobile has been specified as true, we fall into this other condition where we're going to open up a different type of menu. And hopefully I get a chance to show you the different types of menus at the end of the session when we look at the iPhone. But that's one idea of writing JavaScript code. For the vehicle menu that we have, there's also ways that you can declare functions within your own QML types, and you can call these functions directly to help and assist your UI and update your UI accordingly. So back in the application now, we're going to show you a little bit about property binding. So to do that, I'm going to come in here and turn on my location. I'll add a location display, viewshed, and just kind of click on the scene somewhere and add a couple viewsheds to the scene. What we've seen is we have this combo box that's updated to, that's bound to a model, and it's giving me the names of the different viewsheds. And I'll show you that in a little bit, how that combo box can be hooked up to the model. But we also have these sort of property sliders. I've clicked a couple times than I wanted to. Have these property sliders that are hooked up and bound to properties on the viewshed objects. So if I switch back and forth, you'll see those sliders are changing because as I select the different viewsheds, it's binding that slider to the different properties of my corresponding viewshed that I have selected in the combo box. So let me show you how that works. Here we have that range slider for the min and max distance. And the first value we have bound to my controller's active viewshed min distance. And the second value, which is the max distance, we have bound to the active viewshed max distance. Whenever we detect that the range slider's values change, we also want to set those back. So it's important to know that when you're writing properties, you do have to write them back. The binding usually just works for the reading of the property. So quickly, how does that work? I'm going to skip kind of down a little bit because I know I'm running kind of close on time. What ends up happening is behind the scenes, whenever my active viewshed changes, and that's when my combo box is changing, I'm assigning the different active viewshed property, and we're down in C++ code right now. And what ends up happening is we want to make sure that we emit all of these signals for all the different properties that are assigned to the viewshed. And what that's going to do is tell the QML UI that all of these notifications have occurred, that these particular properties have changed. That tells the QML UI, I need to do something, I need to go and read this property back out and update the UI accordingly. The beauty of this is if you're using QML, you don't have to worry about writing the C++ code. The QML API is just going to do this property binding for you. But if you are using C++, you do have to manually, write some code to emit that certain properties have changed and do that logic. So now we'll head back into the slides. And I know I'm running a little short on time here. Models and views. Models and views are really, really powerful for having your data stored in models and updating your views and getting them sent up to the UI. You can visualize each of the elements like I explained before with the delegate. So each sort of row in the list view will have its own sort of delegate that's applied to the row. Models will notify the view, kind of like property binding. The models will notify the view when any of those particular rows' data has changed, and they pretty much will do it for you, which is really nice. And you can bind these list properties to QML views. List properties are typically in our QML API, where we have some properties that are these list types. You can bind these as models directly to QML views. So quickly, let me dive in. I'll go back in and I'll add a couple more of those viewsheds and just show you a really easy example since I'm running a little short on time. Let me add a couple of these location viewsheds just by clicking on the scene. And like I explained before, this particular combo box is hooked up to a model. And I didn't have to write too much code to actually get this combo box hooked up to display the name of these viewsheds. Let's look into the code and see how that's done. So back in the code, we have that combo box. And like I explained, the model's hooked up to my viewsheds model. Now we have this concept of roles. We can hook up the text role to the name role that's defined for my model. And that's all you really need to do. The model will handle all the logic for you in populating that name and pushing that up to the QML UI. And a little bit on how that kind of looks. I guess I'll skip down here. When the QML in C++ code, this is how it looks. If you're using the QML API, you don't have to worry too much about this. And if you're using a lot of the models that are available in the runtime SDK APIs, our models will do all this for you. This is actually what our code looks like internally in our API. The UI will ask for a certain index in the list view and a certain role. So we come in here and we determine which viewshed it is at that index. And then we do a case switch on the role. So for the name role, we're just going to read the viewshed object's name right out and return that back up to QML code. And that's how we're going to see the actual combo box populated with the different names for the viewsheds that's in our list. So that's one example. Models and views are really, really powerful. Like I said, we have a ton of them in our API. We've really tried to expose as many as we can out of our API as possible to hook up to your views. Now, the last thing I wanted to talk about, and I probably am not going to have time to demo this, but is testing and deployment. You can do your testing and your debugging and your deployment all through Qt Creator. And you can also sideload your local data onto your devices. So with Android, you could use some tools on getting data onto your SD cards. And for iPhone, you can use iTunes file sharing to copy data into the Documents folder of your iOS apps. But I know I'm pretty much out of time. So if anybody wants to see a demo of deploying the local data to devices, I'd be happy to show you that a little bit later after this session. So thank you for coming. Please take the survey. Let me know if I covered some good content or if there's other things that you'd like to see if we do a session like this in the future. And thank you for coming. Are there any questions about anything I went over? I know it's all really fast because I only have a little bit of time to cover it, but is there any questions? It was perfectly clear. There we go, question. I don't know if I can walk in front of that. It might give me some feedback.
What's the limitations of the JavaScript?
Limitations of the JavaScript is it's a JavaScript engine that's bundled with the Qt framework. So it's ECMAScript 262 5th edition. You can get access to these objects, but it's not like you're going to get access to additional JavaScript frameworks like Dojo or jQuery and things like that. But other than that, it's really quick. It's running native on your device, and we find it really useful. You can do a lot of cool tricks with JavaScript. I don't believe you can use Ajax with it either, kind of like jQuery. No. Yeah, thanks.
QML is kind of like JSON format with JavaScript inside of it.
Right, so QML is kind of like JSON format with JavaScript inside of it. Exactly. So the declarative code looks a lot like JSON, like you saw in some of the code samples. And then when you're handling events or handling, they call them signal handlers, you're mainly in JavaScript code. And you can call JavaScript code from anywhere, and you can access your QML components by the ID that you define on the QML components. That's kind of its reference back to itself, right?
Thanks, I got it.
Yeah. Any other questions? Great. Yeah, the app that we showed in there was the Dynamic Situational Awareness app, and if you're interested in that, we're giving a demo theater right now about that app in general. So thank you for coming. Thanks for your time.